All right, section 2.8 is on absolute value functions and how we graph them. So to start, we have a few different graphs we're going to do on the same graph paper here in the top right corner. So we're first going to graph just the basic parent graph, which is y equals the absolute value of x. So we're going to put in numbers for x. I'm going to pick 2, 1, 0, -1, -2. So you put those in here. If you put 2 in for the absolute value of x, so what we're going to do is we're going to find out what is the absolute value of 2. It's 2. When you put 1 in, it's what is the absolute value of 1? 1. What is the absolute value of 0? 0. Okay, then what is the absolute value of -1? Positive 1. And what is the absolute value of -2? That's positive 2. So this is the table we're going to graph. This is going to be at 2, 2, 1, 1, 0, 0, then -1, 1, and -2, 2. So this is going to form a V. Yeah, that is the parent graph. These absolute value functions will form a V. The vertex is the point where the V comes together. So the vertex is at 0, 0. And this opens up. So it opens up, vertex at 0, 0, kind of right in the middle of the graph. Okay, I'm going to change colors now for the second one. So for our second graph, I'm going to make it red. Oops, I don't know why I did that. Number 1 is going to be in red. So you pick points for this one. And I'm going to pick the points for you. And I'll tell you why I pick these points later on. But let's pick 3, 2, 1, 0, and -1. Okay, we're going to put these in there. So it's going to be the absolute value of 3 minus 3. So 3 minus 3 is 0. The absolute value of 0 is 0. Then we do the absolute value of 2 minus 3. 2 minus 3 is -1. The absolute value of -1 is 1. And the absolute value of 1 minus 3. 1 minus 3 is -2, so is the absolute value of -2, which is 2. Then 0 minus 3, which is the absolute value of -3, which is 3. And then -1 minus 3 is -4. The absolute value of -4 is 4. So we plot these points in the graph. So I'm going to go up to the graph. And I'm going to put on 3, 0, 2, 1, and 1, 2. And then 0, 3. And then -1, 4. And actually, I'm going to add one more point. Let's put on 4. I messed this up. Let's put 4 in for x. So if x is positive 4, you would get 4 minus 1. Sorry, 4 minus 3. I'm all over the place here. Let me zoom in. This would be 4 minus 3, which would be 1. And the absolute value of 1 is 1. So 4, 1 would be your other point. Okay, so this would also be a V. You can just see that this V is shifted. I'm just going to regraph the whole thing. So 3, 0, 4, 1, 2, 1, 1, 2, 0, 3, and -1, 4. This will form a V like that. The vertex is at 3, 0. It opens up, and it is the same width as the parent graph. Okay, so see that red graph is a little different than the parent graph. It's kind of slid over to the right. Number 2, we're going to pick some points to plug in here. Let's do 2, 1, 0, -1, -2. We're going to put these in for x. So it'll be -2 times the absolute value of 2 plus 5. The absolute value of 2 is 2. So -2 times 2 is -4. -4 plus 5 is 1. Can they do the same thing for 1, for 0, for -1, and for -2? Okay, so -2 times 1 plus 5 is 3. Okay, -2 times 0 is 0. 0 plus 5 is 5. Okay, now the fourth one down, -2 times the absolute value of -1. The absolute value of -1 is 1. Okay, and I'm talking about right here. The absolute value of -1 is 1. So it's 1 times -2 is -2. -2 plus 5 is 3. All right, same thing here. The absolute value of -2 is 2. 2 times -2 is -4. -4 plus 5 is 1. So then we graph this. So 2, 1, 1, 3, 2, 3, 0, 5, 0, 1, 2, 3, 4, 5. -1, 3, and -2, 1. So the vertex for this one is way up here. So the vertex is at 0, 5. It opens down. And you can see the blue graph is skinnier or narrower. It's a little more narrow than the other graphs were. Okay, and the last one we'll do in green. And let's do negative. We'll start with -2, -1, 0, 1, 2. And we'll see if that works out for us. So if x is -2, it'd be 1/2 times the absolute value of -2 plus 1 minus 4. So -2 plus 1 is -1. -1 times 1/2 is the absolute value of -1 is 1. So this will be 1/2 times 1 minus 4. This will be -3.5. Then we do 1/2 times the absolute value of -1 plus 1 minus 4. -1 plus 1 is 0. And 0 minus 4 is -4. Then we do 0 plus 1 in the absolute value. 0 plus 1 is 1. 1 times 1/2 is 1/2. And 1/2 minus 4 is -3.5. And then you keep going, you plug in 1 plus 1. So the absolute value of 1 plus 1 is 2. 2 times 1/2 is 1. 1 minus 4 is -3. And then you would keep plugging them in. But if we were to graph this, we have enough points to graph it right now. -2, 3.5. So -2 down to -3.5. So 1, 2, 3.5 will be right here. -1, -4. 0, -3.5. And then 1, -3. So you can see that this graph is also going to be a V. But this one is going to be a little wider. So the vertex for this one is at -1, -4. It opens up, and this one is wider. It's wider than the parent graph. Okay, so I'm going to point out that if you look at the vertex, 3, 0, 0, 5, -1, -4. So that 1 and the 4 came from here. The 5 and the 3 come from how that equation is written. Okay, we're going to talk about that on the next page and how we can graph these without making a table. There's actually a shortcut kind of way to graph these. So the general form for these equations is y equals a times the absolute value of x minus h plus k. Okay, and the characteristics. If the number in front, or the a value, is greater than 0, then it opens up. So if it's positive, it opens up. If that value is less than 0, it opens down. Okay, so I'll give you a second to look at that. If I go back up, you're going to see what I mean. So if you look, the blue graph is the only graph that opens down. Do you see that there's a -2 in the front? That's why it opens down. Every other graph has a positive number in front of the absolute value, so they all open up. So if it's negative, it opens down, positive opens up. All of these graphs are V-shaped. Okay, and if A is greater than 1, then the graph is narrower. If the absolute value of A is less than 1, then the graph will be wider. Okay, think A is sort of like the slope. That's what I like to think of. A is like the slope. So if we scroll up, let's look for when A is a fraction. As you see in number 3, or the green graph, it's a fraction, it's 1/2. The absolute value of 1/2 is less than 1. So that's why it's wider. If you look at the blue graph is narrower, and the number in front is -2. The absolute value of -2 is bigger than 1, so it gets narrower. So if the number in front is bigger than 1, it gets narrower. If it's a fraction, it's going to be wider. Okay, and the vertex is always at HK. Okay, and I'm just going to point out that H is opposite. Okay, and you'll see what I mean. So if we look at the examples, identify the vertex, determine the direction of opening and the width, and then graph the function. So in number 1, A is the value in front. So the number in front of the absolute value, there's nothing there. That would be a 1. It's kind of like when you have just x, it's 1x. Okay. H is the number inside. So here's A. H is inside and it's always opposite. So what's the opposite of a -3? +3. And then K is the number at the end outside. So K is 1. All right. So if we were to graph this, you could make a table. If you make a table, you could plug in, when you make a table, you put H in the middle. So H would generally go in the middle. And then you put numbers around it. So I'll put like 4 and 2. And I'll plug them in. So you plug in 4. 4 minus 3 is 1. 1 plus 1 is 2. If you plug in 3, 3 minus 3 is 0. You get 1. If you plug in 2, 2 minus 3 is -1. The absolute value of -1 is 1. 1 plus 1 is 2. So you could do numbers like that. You can plug them in, or we can graph the vertex. So the vertex for this is 3, 1. It's at HK. So if we graph the vertex, it's at 3, 1. A is like slope. So the slope, or like the slope, is +1. That means from here, from this point, you go up 1 to the right 1, up 1 to the right 1. And that's going to be half of your V. So if half of your V goes up to the right, the other half will go up and to the left. So we could graph it like that. The table is a longer way to graph it. It's a little trickier, actually. If you find the vertex, and you use the slope, like a as in the slope, it's a lot faster way to graph it. But you can always make a table. So like number 2, let's do the shortcut way. A is -3, because that's the number in front. What number is inside? What is inside by the x? Is there anything in there? And if you look, there's actually nothing. That means h is 0. And k is the number on the outside, so k is 2. So your vertex is at 0, 2. Okay, your a value is -3. So if we were to graph this, the vertex is at 0, 2. If a is -3, that means the slope is down 3 to the right 1. So go down 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. So if we connect these dots, that's half of our v down to the right. The other half of this V-shaped graph is going to be down 3 to the left 1, down 3 to the left 1. So the other half of the V would look like this. So since they're V-shaped, you just make a mirror image. So we have to fill in some blanks. The vertex we said was 0, 2. The direction of opening is down because A is negative. And the width for this one is narrower because A is -3. That makes it go down faster. For the first one, the vertex was 3, 1. The direction of opening was up. And since A is 1, the width we would say is the same. It's not any wider or narrower, because when A is 1, it's just the same width. Okay? And notice in number 2, we didn't even fill our table in because we don't have to graph these. We can graph them in the shortcut way. So we slide down here. Now they're asking us to write an equation for the graph. So determine the value of A and find the vertex to help you start. So A is going to tell us like what our slope is. So we want to find the slope, and we're going to write the equation like this. X minus h plus k. So we need A, we need h, we need k. So A, we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. So it's going up and to the right by 1. That means A is +1. The vertex tells us h and k. So the vertex for this one is at 2, 1. So we know what A is. And again, the vertex tells us h and k. So the equation is y equals 1 times the absolute value of x minus 2 plus 1. That will be the equation for that one. For number 2, A is like the slope. So if you start at the vertex, the next point we would use is like right here. So that would be down 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. So down 3 to the right 1 would be -3. That would be our slope. The vertex is at -1, and the y value is 1, 2, 3, 4. So -1, 4. And again, this is hk. So the equation is y equals -3, then x minus -1 plus 4. So minus -1, just be careful. That's actually going to be plus +1. So it's -3, absolute value of x plus 1, and then plus 4 at the end. Okay, so we can graph these equations, and we can write the equations by using A, H, and K.